All right, so now that we've had a week off to forget everything we know about exponential equations and logarithmic equations, we're going to start solving exponential and logarithmic equations. So the first ones we're going to do are exponential equations. Those are equations that look like this. So like you see 2 to the x, that's an exponential equation. And one of the things we're going to use is something called a one-to-one property of exponential functions. And that just says that if b to the x is equal to b to the y, then it should make sense that those two exponents, x and y, are equal to each other. So if you have the same base, that's basically the big idea here. If we have the same base, then the exponents, whatever they are equal. So a real quick example would be like if we had 3 to the x equals 3 squared, well then that means that x equals 2. A little more complicated example of that would be if we had 2 to the x minus 1 equals 2 to the 2x plus 3. We see that we have the same base, so then our exponents are equal. So x minus 1 would equal 2x plus 3. So if we move this x over, we would get x equals, and then we subtract 3 from both sides over here, negative 4. Okay, so we're gonna be solving equations, but they're gonna start out as exponentials, and we're gonna simplify them down to something we can do very easily because of this one-to-one property. So we see 2 to the x equals 4. Remember, for the one-to-one property to work, you have to have the same base. So 2 and 4 are not the same base, but 2 to the x is equal to 2 squared because 4 is 2 squared. So we try to make the bases the same, and once we have, we just set the exponents equal to each other, and we're done. So here we have 3 to the x plus 8. Well, 3 to the x plus 8 equals 9 to the x. Well, 9 is not the same as 3, but we know that 9 is 3 squared, right? So 3 squared to the x is the same as 9x. And you know that when we have exponents inside the parentheses and exponents outside the parentheses, we just multiply them together. So this says 3 to the x plus 8 equals 3 to the 2x. And now we have the same base. So we're going to write x plus 8 equals 2x. And we'll subtract x from both sides and get x equals 8. Not so bad. So here we have a 1/2 to the x plus 8 equals 8 to the 2x. Well, you want to think, how can I take this 1/2 and this 8 and make them have the same base? Okay, so this 1/2 is really 1 over 2 to the first. And so you know that that 1 has to be negative for this 2 to wind up on the bottom. So that's really 2 to the negative 1 to the x plus 8 equals, and now 8, you know, is 2 cubed to the 2x. And now we're just going to multiply our exponents, but remember when you do this part, you have to distribute to the x and to the 8. Our bases are the same now, so we don't need them anymore. So this is negative x minus 8 equals 6x. And I'm going to add x to both sides, so I'll get negative 8 equals 7x. Divide both sides by 7, and I'll get negative 8 over 7 equals x. All right, last one. Need to make the bases the same before we do anything. So we're going to have 4 to the x minus 2 equals 4 squared to the x plus 4. Remember, we want to distribute this 2 throughout that x plus 4. So we're going to have x minus 2 equals 2x plus 8. So we subtract x from both sides, subtract 8 from both sides, and we get x equals negative 10. So that's the one-to-one property. Remember, the key to this, the key important thing, is that we make the bases the same. Once you do that, you can just stop writing them. All right, so there's a couple of strategies for solving exponential equations, and you just saw one of them. The first And the easiest strategy is to rewrite the original equation in a form that allows us to use the one-to-one property. Okay, if that doesn't work, you're going to rewrite the original equation in a form that allows us to use the inverse property of exponential properties. And that's just a fancy way of saying logs. So we're going to use logs. So here are a few examples where the one-to-one property is not going to work, because if you look at this 4, well, you say, well, I can make that 2 squared. But you can't do anything with that 13, so you're really just kind of stuck. There's no opportunity to use the one-to-one. So for these, if you want to make a little note, these are where we're using the inverse property. And you know that that means logs. Logs are the inverses of exponents. So it's very simple. And we have a base 4 to the x. And what we want to do when we're solving anything for x is we want to get the x by itself. Well, something that would make this 4 go away, and this is part of your log properties, is if we took log base 4 on both sides. So let's write that and just see what it looks like. So log base 4 of 4x equals log base 4 of 13. And so what we've done is we've done this log base 4 on both sides. Now that's okay, because as long as you do the same thing to both sides of an equation, it doesn't matter what you do. You can add stuff, you can subtract stuff, you can log stuff, and that's what we're going to do, is log. So when we do log base 4 of 4, you know that that just cancels those and makes it an x, right? The log base 4 of 4 cancels it. It's actually 1, but we're going to go with cancels. All right, and then log base 4 of 13, if you've got a calculator that will do that, remember you do math, you go down and you hit log, a base, something that's down at the bottom, and you type it in. All you have to really do is this in your calculator, and that's going to equal 1.9 because it says round to the nearest tenth. So don't worry, we'll practice a few times. Now we have e to the 4 minus 3x equals 6. Well, e and 6 you're not going to be able to make into like bases. All right, so let's think about what undoes e. Well, hopefully you remember that ln and e are inverses of each other. So when we do the natural log of e, that eliminates it. So do the natural log to both sides. The ln e, the natural log of e, is going to cancel, and we're going to have 4 minus 3x equals ln 6. Okay, this is just like any equation. You have an ln button on your calculator, so that shouldn't be a problem. We're going to subtract 4 from both sides, so negative 3x equals ln 6 minus 4. Divide everything by 3, and x is going to equal ln 6 minus 4 divided by 3. And you're going to type all that in your calculator and get that x is equal to 0.74. All right, example 4, we have 2 to the x plus 4 equals 5. Again, we're not going to be able to get those bases the same and use our one-to-one property. So we are going to log base 2 of 2 to the x plus 4 and log base 2 of 5. Remember, if you're confused about why are we doing log base 2, why don't we do log base 5? We're trying to eliminate the base of the exponential equation or function. So the 2 to the x plus 4 is what we need to kind of rewrite. We don't really care about the 5. We're just going to jam it in the calculator when we're done. So log base 2 of 2 just gives us x plus 4. And log base 2 of 5, we haven't done yet, so we're going to subtract 4 from both sides. We get x equals log base 2 of 5 minus 4. And if you're doing that in your calculator, you want to do log base 5, or sorry, log 5 divided by log 2 minus 4, hit enter, and you get negative 1.7. All right, last one. Base 4 and base 3. We know they're not going to be the same, so we can't do anything simple, we're going to have to do log base 4 of 4 to the 3x minus 1 equals log base 4 of 3 to the 2 minus x. Now, you might notice that didn't really, it's not going to get rid of our 3 over here, right? Because all the other ones we've done, we just had an x on one side, but this one we have an x on both sides. So it's not ideal. This isn't the favorite kind, but this is how we're going to do it. So log base 4 of 4 cancels. So now we have 3x minus 1 equals, now this is an exponent, right? So with our log properties, we can bring it down in the front here, can't we? So this can be 2 minus x. And log base 4 of 3, you can do that in your calculator. Log 3 divided by log 4, and you get 0.792. Okay, so I brought my exponent down to the front, and I calculated my log right there. Okay, so now I have 3x minus 1. I'm going to distribute this into this parentheses. So 0.792 times 2 is 1.584, and then times negative x is just negative 0.792x. Now I'm going to add this, so we'll write it down, plus 0.792x and plus 0.792x. So now I'm going to have 3.792x minus 1 equals 1.584. I'm going to add 1 to both sides, just like any algebra problem, except we got some decimals in here. All right? And then we're going to divide both sides by 3.792, 3.792, and we get x is equal to 0.7. Remember, we're rounding to the nearest tenth. All right? So that's it. That's solving exponential equations and logarithmic equations. We'll work on it more tomorrow. It'll get a little more challenging, but not too bad.